So we're now up to Chapter 7, Lesson 2, and we're going to be working on solving linear systems by substitution. And a linear system is two sets of equations, and we did this before with graphing linear systems and then seeing where the two lines cross in the previous lesson. But now what we're doing is instead we're going to go ahead and solve one of them for one of the variables. That's what is happening here. We're going to solve for y by changing around this first equation. Then we substitute in y's value into this equation for y. And then what's happening is then we're going to figure out what x's value is, and then we're going to figure out what y's value is from there. So let me walk you through this because I think it will make more sense as we talk about it. So here the first step is to solve the equation for y or x. It doesn't matter which one, provided you have a plan for one or the other. So for this here, this one's pretty easy to solve for y. I just subtract 2x from both sides. So now I've got this here. That's my y value. And it's in a slope-intercept form, but that's not important. It's just that I have it so y is on one side and x is on the other. So now I'm going to take this negative 2x plus 1, and that's my value of y, and I'm going to plug that in here. And so that's what's happening here. X plus 2 times the value of negative 2x plus 1. And the negative 2x plus 1 goes there. It's from there. And that is equal to 5. So it's x, when I distribute the 2, it's going to be x minus 4x plus 2 is equal to 5. Then I'm going to subtract 2 from both sides. Then I'm going to divide both sides by negative 3. And I get x is equal to negative 1. So that's going to be my first part of the coordinate. So now I'm going to substitute negative 1 into one of these two equations that's at the top. And I'm going to figure out what corresponding value of y is. In this case here, it's going to be 3. That's what's happening in this step here. Then after that, I'm going to test this one more time to see if it works by plugging this coordinate into both of them. And if it's true for both of them, that is the point at which the two lines cross. So let's see here. I'm going to do this problem here. So first things first, I'm going to solve. It does not matter if you solve for x or y, but in this case here, that one here just screams for being solved for x. So it's going to be x is equal to 4y plus 9. Because all I did was I added 4y to both sides. Now I'm going to do this. Over here, I'm going to go ahead and do plug in the value of x where that 2x is. So now it's going to be 2 times 4y plus 9. And then don't forget the plus 5 part, plus 5y part. That's equal to 5. Distribute that 2, so it's going to be 8y plus 18 plus 5y is equal to 5. Combine like terms, so 13y plus 18 is equal to 5. Subtract 18 from both sides. And now divide both sides by 13. So it's going to be negative 1 is going to be the y's coordinate when the 2 points cross. So negative 1 is that second part. Now I'm going to plug in negative 1 into one of these two equations for the y value, and I will get a corresponding x value. So if I do that, it's x minus 4 times negative 1 is equal to 9. So this is going to be x minus, or it's going to be actually plus, in this case here, it's going to be plus 4 is equal to 9. Subtract 4 from both sides to get x is equal to 5. So remember that there, and then I'm going to plug that point into both of these two. I'm going to see if it's true. So let's try that out. So here, it's going to be, for the first equation, it's going to be 2 times 5 plus 5 times negative 1. Is that equal to 5? Yes, it is, because that's 10 plus negative 5. That's equal to 5. Now the second one, it's going to be 5 minus 4 times negative 1 Is that equal to 9? Yes, it is, because that's going to be 4 plus, or 5 plus 4. So that's basically how it is. I'm not going to do this problem. I'm going to do one on this next page. So the advantage of doing it this way is no matter what, you're going to get an exact point. I know that graphing can be easier, but in this case here, you're going to get an exact point no matter what. So even if it's a fraction, you still can solve it. So, for example here, I'm going to immediately choose to solve for this one right here. Because I'm going to change it a little bit. I'm going to change it so that it's going to be 5x. I'm going to bounce the y over to the other side is equal to negative 21 plus y. And now I'm going to bounce the 21 back over to the other side because I'm going to add 21 to both sides. So that's my new equation. It's the same thing. It's an equivalent expression. It just is something where now I've got this here, and I can plug that into this second equation. You always have to plug it into the different equation, otherwise it won't do you any good. So let's try this again. So here, for this one here, I'm going to rewrite this. It's going to be 8x plus 5 times this value here, 5x plus 21 is equal to 6. So this is going to be 8x plus 25x plus 105 is equal to 6. Combine like terms, 33x. I'm going to subtract 105 from both sides. I'm going to end up with 99, negative 99. Is that right? Let's see here. No, it's actually, I think it is. Wait 1 second. Yeah, that's right, negative 99. So x is going to divide both sides by 3. X is going to be equal to 3. Negative 3, excuse me. Negative 3. So that's my first part of my coordinate. So now I'm just going to plug in that into one of these other equations. So 8 times that negative 3 plus 5 times y is equal to 6. So this is going to be 24, well, negative 24 plus 5y is equal to 6. So add 24 to both sides, you get 5y is equal to 30, and y is going to be equal to 6. So now I'm going to plug that negative 3, 6 into both equations to check them. And when I do, I get 8 times negative 3 plus 5 times 6. Is that equal to 6? Well, this is going to be negative 24 plus 30, and that is indeed equal to 6. So for the second equation, it's going to be 5 times negative 3 minus 6 is equal to negative 21. Let's see if that works. 5 times negative 3 is going to be negative 15 minus 6 is equal to negative 21. So this here works for both, and therefore it's the solution for both. So that's how you can work on these, and hopefully that makes that's clear. Thanks, and bye.